In the problem-solving intelligent agent, the problem formulation is the important task. The formulating problem is the process of translating a real-world task and a goal into precise, formal representation that a problem-solving agent can handle using search algorithm. In this, it converts a formal goal into searchable problem. This defines what the agent can do and what counts as success. This also enables applications of uninformed and informed search algorithms. Also controls state space size through abstraction. This formulation of problem includes 6 states. The first one is initial state that specifies the starting point of the agent, where the agent has to start its execution, that is specified by this initial state. State space includes all the possible reachable states from the initial state. Actions includes the legal actions available to the agent in order to achieve the goal state from the final state. The transition model provides a list of actions, possible actions that can be applied in order to achieve the goal state. Goal test provides the conditions which decides a state reach the goal or not. Path cost function is used to measure the cost of a solution. This problem formulation represented using a simple algorithm. This algorithm includes the statement of the various possible states and which is the initial state and a goal to be achieved. It starts with initial state. From that state, it has to choose the possible state from the list of state. A well-defined problem is normally contains precise semantics and clear success conditions. A problem can be defined formally by 5 components that we discussed already. The initial state specifies the agent's starting configuration. This acts as a root node of the search tree. This must be described using the chosen state representation. The action or successor functions defines the mapping of reachable state from the initial state. This specifies all legal actions applicable in a state, determines the branching factor of the search tree. The transition model describes how actions affects the environment. Normally, it defined as a result of S comma A is equal to S dash must be the deterministic in classical problem solving and enables prediction for future states. Goal test defines the given state satisfies the goal conditions or not, thus applied to each generated state during search. A separate goal definition from path cost optimization is normally used. The path cost is nothing but a function assigns a numeric value to a sequence of actions. This is usually defined as sum of step cost. This allows comparison between multiple solutions, essential for identifying optimal solutions. And the problem formulations include state space that together provides actions, initial state, actions and transition defined state space. State space is the complete set of states reachable from the initial state. This forms a directed network or graph. In this nodes are states and the link between nodes are actions. In the state space, a path is a sequence of states connected by sequence of actions. Goal test determines whether a given state is a goal state. A path cost function assigns a numeric cost to each problem-solving agent. Choose a cost functions. This is represented by a graph. The graph includes repeated states. A search tree includes during the exploration it is specified it includes only the selected states and selected paths. Solution is a sequence of actions that transforms the initial state into goal state. A solution is evaluated using pathcast. Search is the computational process of exploring the state space. It systematically applies the successor function starting from the initial state, also produce a solution or a failure if no solution exists. Agent execution that does not execute during the search time. After searching process, the agent executes the first action of the solution sequence.